They said railways were locked into one future: steel tracks, diesel engines, overhead power lines stretching for miles. For more than a century, trains followed the same rules: burn fuel, draw from the grid, or don't move at all. Until Africa started asking a different question. What if rail transport didn't need fuel, didn't rely on massive electrification projects, and didn't wait for trillion-dollar infrastructure upgrades? That question didn't come from a global rail giant or a Western research lab. It emerged quietly from engineers, inventors, and transport planners working under constraints most of the world ignores. Because in many parts of Africa, rail isn't a luxury. It's a lifeline. And when lifelines fail, innovation doesn't follow tradition. It rewrites it. What's now being described as a self-powered train didn't begin as a headline. It began as a problem: how to move people and goods reliably across long distances where fuel is expensive, grids are unstable, and maintenance budgets are thin. The solution wasn't bigger engines. It wasn't more fuel. It was rethinking energy itself. Early concepts focused on efficiency first: extreme efficiency, reducing losses, recycling motion, capturing energy that traditional systems waste without a second thought. Some designs explored regenerative systems far beyond conventional braking. Others integrated onboard energy storage in unconventional ways. And a few prototypes began experimenting with hybrid self-sustaining loops, systems designed to stretch limited inputs farther than ever thought practical. Quiet tests followed: short routes, controlled environments, no press. And then something unexpected happened. The trains didn't just move, they kept moving. Not endlessly, not magically, but long enough to force engineers to pause and recheck their assumptions. Because if a train can operate for extended periods with minimal external energy input, the economics of rail transport begin to shift. Fuel costs drop. Infrastructure demands shrink. Maintenance models change. And suddenly, regions once considered too expensive for rail expansion start looking viable. That's when the idea stopped being local. Transport analysts started paying attention. Rail planners began asking questions. And quietly, global observers started noticing that Africa wasn't copying rail technology anymore. It was rethinking it. But here's the part rarely discussed. This isn't about breaking physics. It's about exploiting efficiency gaps that traditional systems ignore. Modern rail systems are powerful, but they're also wasteful. Energy lost to heat, to friction, to outdated design assumptions built around cheap fuel and centralized grids. Africa's approach flips that logic. Instead of assuming energy abundance, it assumes scarcity and designs accordingly. And that design philosophy may be its greatest breakthrough. And once every what matters, the entire system changes. Weight becomes the enemy. Drag becomes unacceptable. Idle energy loss becomes a design failure, not an inconvenience. So these new rail concepts strip everything down to necessity. Lighter materials, smarter load distribution, modular components that can be serviced without shutting down entire routes. Even the way the train accelerates and decelerates is rethought: smooth curves instead of brute force, momentum treated as an asset instead of something to constantly fight. In traditional rail systems, energy is spent aggressively and recovered poorly. In these emerging African designs, energy is treated like a closed loop, not perfectly closed, but tight enough to matter. And that's where the phrase self-powered begins to be misunderstood. It doesn't mean the train creates energy from nothing. It means the train wastes almost nothing. By harvesting braking energy more efficiently, by stabilizing onboard storage across long routes, by reducing dependency on external refueling intervals, the train becomes operationally independent for long stretches. Independent enough to change planning assumptions. Independent enough to reduce costs dramatically. Independent enough to function in regions where traditional rail would never be approved on paper. And that's exactly why this matters beyond Africa. Because the global rail industry is built on legacy thinking. On models created for wealthy nations with stable grids, abundant fuel, and decades-old infrastructure already in place. Africa doesn't have that luxury. So instead of copying old systems, it's leapfrogging them. Just as mobile banking leapfrogged physical banks. Just as solar leapfrogged centralized power in rural regions. Rail is next. And that's making people uncomfortable. Because if self-sustaining rail systems prove viable at scale, they don't just lower costs, they disrupt suppliers, fuel contracts, electrification projects, and billion-dollar infrastructure plans. That's not something industries adapt to quickly. Which is why much of this work remains quiet. Pilot routes instead of press releases. Engineering papers instead of marketing decks. Performance data instead of slogans. But the signs are there. Longer runtimes between refuels. Lower operating costs per kilometer. Reduced dependence on imported energy. And for countries balancing development with sustainability, that combination is powerful. This isn't a single train. It's a design philosophy spreading across transport planning offices. And once that philosophy takes hold, the question stops being, can this work? It becomes, because when that question starts circulating, it rarely stays contained. Rail planners begin reevaluating stalled projects. Engineers revisit assumptions they were taught never to question. Policymakers quietly ask whether billions earmarked for fuel imports or grid extensions could be redirected elsewhere. And slowly, almost imperceptibly, priorities shift. What's especially striking is where this shift is happening first. Not in glossy innovation hubs. Not in countries with endless capital. But in regions where failure isn't an option, because transport isn't optional. In those contexts, a train that can operate with minimal external energy isn't just efficient. It's resilient. It keeps moving when fuel supply chains break. It keeps running when grids fail. It keeps communities connected when conditions turn unstable. That resilience is what makes these self-powered rail concepts so attractive and so quietly studied. Because resilience doesn't grab headlines, but it wins long games. And while critics focus on whether the term self-powered is technically precise, engineers focus on something else entirely. Outcomes. Does it move people reliably? Does it reduce costs over time? Does it survive real-world conditions? If the answers trend in the right direction, the terminology becomes secondary. That's why no one is claiming the end of fuel overnight. No one is promising perpetual motion. What's being built is more pragmatic and arguably more dangerous to the status quo. Systems that need less fuel. Systems that rely less on centralized power. Systems that function where traditional rail would never be approved. And once those systems prove themselves locally, scaling becomes a matter of iteration, not reinvention. That's the part global observers are watching closely. Because if Africa succeeds in making rail transport cheaper, more resilient, and less energy dependent, not through massive spending, but through smarter design, it challenges the assumption that progress must always be expensive. And assumptions, once broken, don't return quietly. They collapse. Which is why this story isn't about one train or one country. It's about a shift in thinking. A reminder that innovation doesn't always come from abundance. Sometimes it comes from constraint, and that speed is exactly what makes established systems nervous. Because once a cheaper, more resilient alternative exists, even on a limited scale, it exposes how fragile the old model really is. Diesel-heavy rail systems depend on stable fuel markets. Electrified rail depends on massive grid reliability. Both assume predictability in a world that's becoming increasingly unpredictable. Africa's rethink of rail transport doesn't assume stability. It assumes disruption. That mindset changes everything. Instead of building railways that work only when conditions are perfect, these systems are being designed to work when conditions are flawed. When fuel deliveries are delayed. When power fluctuates. When budgets tighten. When climate stress pushes infrastructure to its limits. And that's why this approach resonates far beyond the continent. Because the challenges Africa faces today are the challenges the rest of the world is moving toward tomorrow. Rising energy costs. Aging infrastructure. Pressure to decarbonize without crippling economies. In that context, a train that can operate with drastically reduced external energy input isn't a niche experiment. It's a preview of what transport looks like when efficiency becomes survival, not just optimization. What's emerging is a new definition of progress. Not faster, not bigger, but smarter, leaner, more adaptive. And while the global rail industry debates terminology, Africa is quietly testing reality, route by route,
System by system.
assumption by assumption. Because once those tests accumulate, once data replaces theory, the conversation changes again, because catching up won't be simple. What Africa is experimenting with isn't a single train or a one-off prototype. It's a shift in how rail systems are conceived from the ground up. Energy capture, storage, and reuse are being treated as core design elements, not add-ons bolted on after construction. These trains are being optimized to harvest energy wherever motion exists. Braking systems designed to reclaim power instead of wasting it as heat. Lightweight materials that reduce drag without sacrificing durability. Smart routing algorithms that adjust speed profiles in real time to minimize consumption across entire corridors. None of this sounds revolutionary on its own. But together, it changes the math. Suddenly, a train doesn't need constant external input to stay operational. It needs less, and sometimes far less than traditional systems assume. That difference determines whether a rail line survives budget cuts or shuts down. And here's where the story gets even more interesting. Because these experiments aren't happening on pristine, high-tech corridors built for headlines. They're happening on challenging routes, long distances, harsh climates, inconsistent maintenance environments. The kind of conditions where theory usually collapses. Yet instead of failing, the systems are adapting. Engineers are learning faster because mistakes are expensive. Designs evolve rapidly because solutions must work, not just impress. And that pressure is producing something rare in modern infrastructure. Practical innovation. Innovation driven by necessity, not prestige. And as results begin circulating through engineering circles, transport ministries, and logistics firms, attention quietly shifts. Not publicly. Not with press releases, but through feasibility studies, closed-door meetings, pilot inquiries. Because if these concepts scale, and that question is now when, not if, they don't just alter Africa's rail future. They rewrite assumptions globally. Fuel dependence stops being inevitable. Grid reliance stops being absolute. Energy efficiency stops being optional. And once those assumptions fall, every rail network in the world has to reevaluate its foundations. But that reckoning hasn't arrived yet. For now, the trains keep running. And that's where this story truly comes to rest. Not with a dramatic press conference. Not with a viral announcement. But with something far more powerful, proof through persistence. Africa's self-powered train experiments are not claiming perfection. They're asking a better question. What if rail transport didn't have to depend so heavily on fuel at all? What if efficiency itself became the primary source of power? That question is now moving faster than skepticism. Because every successful run challenges long-held assumptions. Every kilometer traveled without traditional fuel weakens the argument that this can't be done. And every data set gathered brings the concept closer to large-scale reality. This isn't about replacing every train overnight. It's about reshaping the future of transport step by step. If these systems continue to evolve, the impact won't be limited to Africa. It will influence how railways are designed, funded, and operated worldwide, especially in regions facing rising fuel costs and fragile energy grids. History often remembers moments like this quietly. Not when something becomes perfect, but when it becomes possible. And right now, on African rail lines few people are watching, the impossible is slowly becoming operational. If you found this story thought-provoking, stay curious, stay questioning, and keep watching the places the world tends to overlook.